In the figure shown, compute the gauge and absolute pressure at X when fluids A and C are air. Fluid B is mercury with G 125 mm. Fluids A and C are water. Fluid B is mercury, Z 600 mm, Y 400 mm. Then fluid A is water. Fluid C is glycerin, specific gravity of glycerin 1.26. Fluid B is carbon tetrachloride, specific gravity 1.5. Z is 800, Y is 500. So for the first fluids A, air, air, the pressure here is 0. We go up, so the pressure anywhere in the airspace is the same. So therefore, it is expected negative. Beginning here, we sum up pressure at this surface, 0. Fluid B is mercury, so minus 13.6 times 9.81 times 0.125 meter, 13.6, 9.81 times 0.125 meter, equals, the pressure here is the same anywhere because these fluids are air. So equals pressure at X. So the pressure at X is negative 16.68 kilopascals. The absolute pressure at X is gauge pressure at X plus 101.3. So absolute pressure at X is negative 16.68 plus 101.3 at standard atmospheric pressure. So it is 84.62 kilopascals absolute. For the second part, fluids A and C are water. So this is water. So the pressure here is no longer equal to the pressure at X. So beginning with here, this point, 0, fluid B is still mercury. So minus 13.6 times 9.81 times Z, which is 0.6 meter. That's the pressure here. Then we jump across here because this is water. So minus plus 9.81 times Y, which is 0.4, then equals pressure at X. So pressure at X is negative 76.13 kilopascals. The absolute pressure at X is negative 76.13 plus 101.3. So the absolute pressure at X is 25.17 kilopascals. Then last problem. So still fluid B is this time carbon tetrachloride. Fluid C is glycerin. Fluid A is water. So fluid A does not affect because it only occupies the vessel, the pipe. So beginning with this pressure is 0. Then because this fluid B is carbon tetrachloride, so specific gravity 1.5. So minus 1.5, 9.81 times Z, which is 0.8. Then that's now the pressure at this level. This is occupied with fluid C, which is glycerin. So we jump across here, same pressure. So plus specific weight of glycerin, 1.26 times 9.81 times 0.5. Y is 0.5, then equals pressure at X. So the pressure at X is equal to negative 5.592 kilopascals. Then the absolute pressure at X is negative 5.592 plus 101.3. So the absolute pressure at X is 95.71 kilopascals.